Okay. So see, we have discussed about a problem. If you see, we have discussed about a problem, this one, this problem we have discussed, where you see this is a arch and this is a parabolic arch. For that the equation was given, you see, the equation of the parabola was given like this: 4hx by L square into L minus x. And for this arch, we there is a point load at a distance of 4 meter from the left hand support, and you are asked to find out what will be the values of bending moment and other things at this point E, and also the complete bending moment diagram of this arch. Now you see, instead of this point load, if a if a UDL uh, UDL is acted upon on that arch, and if the UDL is acting on part of the arch, then what will happen? So let's see, let's try to have a look at this. So let's see, let's have a look at this problem. You see, this is a problem, typical problem. You see, the equation of the axis of a 3-hinged arch is y is equal to x minus x square by 12. Everyone can hear me?
Yes, sir.
Yes, sir.
Okay, can you see the screen? Screen is clear? Screen is clear, or should I make it a little bit larger?
Yes,
Is it clear
clear,
now?
sir.
Okay. So you see, there is a this problem says about, talks about a 3-hinged arch. So first thing is, 3-hinged arch is basically, you should remember, again I am repeating, it's a determinate structure, and the equation of the axis of a 3-hinged arch is y is equal to x minus x squared by 12. That means the equation of this curved portion is basically, this curved portion is y is equal to x minus x squared by 12. The origin being the left hand support, the span and rise are 12 meter and 3 meter respectively. So you see the span of the arch. So what is the span of the arch? From one support to the other support, this is the span of the arch, and this is the rise of the arch. So from the base of the arch to the crown, whatever is the distance or whatever is the height, that is actually your rise of the arch. So rise of the arch is given as 3 meter. The left half, it is written as let, okay, so it's not let. Left half of the arch is loaded with a uniformly distributed load of 30 kilonewton per meter. You see, this in this problem, one problem we have solved where a parabolic arch was completely loaded with UDL throughout its span, but in this problem you see the load is only on the half portion of the arch. So one half of the arch up to the crown, one half of the arch is loaded with a distributed load of 30 kilonewton per meter. Now the question is given that you need to evaluate the reaction components at the supports, then the moment, radial shear and normal thrust. So you understand now what is radial shear and what is normal thrust. If you remember, I have discussed in detail about it when you have discussed about the problem of that point load acting on the arch, and exactly the same way you will have to find out the radial shear and normal thrust. Okay, and where you will have to find out? You will have to find out it at a section 3 meter from the left hand support. So basically 3 meter from the left hand support means somewhere, this is your left hand support, this A is your left hand support. So somewhere from this left hand support to a distance of 3 meters. So this distance is your 3 meter. At a distance, you see a section is being given. So at this section you will have to find out, that means at point D you will have to find out how much will be the moment, how much will be the radial shear, and how much will be the normal thrust. Okay, so that way if you see, the problem ideally remains same as we have discussed it earlier, right? So what is the first step you will have to do? you will have to in the first step you will have to find out the vertical reaction components and the horizontal reaction components, because you see it's a 3-hinged arch. So basically this support A is a hinge support and support B is also a hinge support. So at the support A there are two reaction components, one is vertical reaction VA, another one is horizontal reaction H, and exactly the same way at the support B, if you observe, there is a vertical reaction which is VB and a horizontal reaction H. See, basically this can be HA and HB, but if you notice, if you observe in this case, this arch is not acted upon by any other horizontal forces. So whatever the horizontal reaction component will be coming at the support A, exactly the same reaction will be coming at the support B. So HA, value of HA is going to be equal to HB, which is given as, which is B equal to H. So now to find out the reaction VA and VB and H, the first step, what you will have to do? So first you will have to do the evaluate the reaction components. So how do you evaluate the reaction component? You will have to take moment about some support, or you will have to take moment about the hinge point. Now if you take, let's say, moment about this point A. So if you take this moment about this point A, so if you take the moment about point A, then you see, if you take the moment about point A, then moment about the hinge support A. So how much will be the moment about hinge support A? So if I take it out from here, so let's say, and then let me paste it over here, so it will be little bit, where should I paste it? Here, let's say here only. So now you tell me what will be the moment about A. So if I take moment about A, that means if I take MA, moment about support A, and if it is subscripted like this, so summation of all the forces of moment about A, if I take, then what will happen? This VB is going to create moment about this point A, right? And also this H is going to create any moment about this point. Will it create any moment about this point A? No, it is not going to create any moment. So what will happen? So summation of sum of all the moments about A needs to be equal to 0. So if you do that, then what will happen? Then you see the previously, as we have discussed, this VB is going to create a moment. This VB is going to create a moment about A, and how much will be the moment for this VB? VB into 12, right? So this, if I take, if this point will be rotated in a anti-clockwise direction. You see the direction of this rotation will be in this way, right? Anti-clockwise. So if the rotation is anti-clockwise, let's keep it positive, and then you see this horizontal reaction force is not going to create any moment about this point, because the point of action of this horizontal force will be passing through this, and then you observe this force, this UDL is going to create a moment about this point, point A, and how much will be this moment? You see this moment will be minus, because this is going to create it a clockwise moment. In this way it will be trying to rotate. So if I take clockwise as negative, then it is going to be total force is 30 multiplied by how much will be the distance? This distance is half of the span of the earth, so the total span of the earth is 12 meter. So this is actually half of the span, that means 6 meter, and this is going to be acted upon at a distance which is basically, if you take this total load 30 into 6, and if what in case of UDL, how do you calculate the moment? You calculate the total load and then assume the total load is acting at the middle of the support, middle of the load, right? Equivalent total load is acting at the middle of the load, and then you take the moment. So how much will be the distance? The distance will be 6 by 2. So if you solve it, if this is going to be equal to 0, and from that you should be able to calculate the value of VB, right? So how much will be the value of VB? Can anyone tell? Can anyone tell how much will be the value of VB? If you can calculate, please. Anyone?
Sir, 45, sir.
45, it is coming 45. So you are getting 45 kilonewton. Exactly correct. So you see 45 kilonewton. Is it okay? Everybody have understood it? See, now you should understand it very clearly, how to take moment and then how to find out these reaction forces. If you cannot find out reaction forces, you cannot solve this structure at all. Okay. Now after you found out the value of VB, what is the next? Next is the finding out of this horizontal force H, right? So for finding out horizontal force H, you see, if you go from this side, then you see you need to know first VA. Without finding out VA, you cannot find out H, okay? Because otherwise two unknown components will come. So let us go from the right hand support, and you see at this C, that means at the crown of the arch, there is a hinge, okay? So basically this is a 3-hinged arch, and if you remember, there is a 3-hinged arch means there is a hinge over here. So there is a hinge over here. So when there is a hinge over here, what you can do? We can say that the sum of all the moments, about the hinge, that is actually the C, should be also equal to 0. Okay. Now considering this, you see, now you know this VB, the value of VB is known. So if you consider only this left portion, right portion, right? This is the right portion. So this, if you consider only this right portion of this arch, and take moment of only these two forces about this C, you see your VB is already known, so you will be able to calculate H very easily. So what will be your moment about MC? Then what will be your moment about C? Moment about C is going to be nothing but VB. So it's going to be VB. So VB multiplied by how much it will be? So you are taking moment about this point C. So the distance from this point B to this
6.
6. So will it be positive or negative? So basically you see this VB will try to rotate this point C in the anti-clockwise direction only, right? So this is going to rotate this point. So if I consider this as lever arm, so this VB will try to rotate it in this way. So basically this is anti-clockwise. So if we consider anti-clockwise as positive, so VB into 6, it will remain positive. So let me replace this VB now by 45. So you should be now clear that why it is 45. Now minus, so see this H, if you think, So this H, the action point of this will come over to here, and their lever arm distance will be the rise of the earth. So this is going to be H multiplied by, how much should I write? 3. So this H is going to be creating a moment about C, which will be nothing but this H multiplied by this distance, the rise of the arch. So this is going to be equal to 0. Okay. So from this equation now we should be able to find out, the value of H. So what will be the value of H, you tell me?
Sir, 90.
90. 90 is coming.
90, sir.
135 I am getting. So anything I am missing? No.
VA value है sir, VA value.
H,
That is V.
H is 90. Excellent. Correct. H is equal to 90. Correct. Very good. So we have got the value, right? So VB is this and H is 90. Is it clear to everyone? If anyone has got any doubt, please ask. Okay. Next what you have to do? So what is the question? Question says you find out all the reaction components. See, whether it says you find out all the reaction components or not, you'll have to first find out all the reaction components, right? So we are finding out reaction components. So we have found out VB and we have found out VB, as well as we have found out H. Now what will be the value of VA? Can anyone tell? What will be the value of VA? So how do I find out VA? Again I need to take moment about any point, or from other condition should I be able to get the value of VA? Should I need to take moment about the point B to find out VA, or I can apply some other condition so that I can find out VA directly? Can anyone tell?
So
Say
summation of
summation
vertical
of-
force.
Yes, very good. So summation of all the vertical forces can be equal to 0, right? So what are the summation of all the forces? Summation of all the forces are nothing but this VA. So VA is the vertical force. Let's say this is upward. So upward, let us take positive. So VA is the upward force, and then there is a VB. So there is a VB force acting upward. So let us put it here. So this is your VB, and then there is a downward force acting. There is a downward force acting, and what is the downward force in this case? The downward force is nothing but this 30 multiplied by 6, right? So 30 multiplied by 6, your downward force. This should be equal to 0. So summation of all the forces in the vertical direction or in the y direction is equal to 0. We are applying the condition of equilibrium in this case, vertical equilibrium in this case, and we can find out the value of VA, because you see VB is already known to you. So VB is 45. So if we solve the value of VA, then you can easily get the value of VA. And what will be the value of VA? Calculated value of VA is going to be equal to 180 minus 45, that is going to be equal to, I think, 135, right? So here I should write kilonewton, and then this is also kilonewton. So is it clear? Okay. So you see, we have now done the first steps. So step 1, to evaluate the reaction components. So we have calculated this much. Everything is clear. Now the next question is you find out the moment, you find out the radial shear, you find out the normal thrust. Okay. So now you have idea about the normal thrust and radial shear. Already you have solved one problem. Okay. So first let us try to find out what is the moment. So how do you find out the moment? Can anyone tell me from this problem definition? What you will have to do? Where you will have to find out the moment? where you will have to find out the moment. What is the question saying? So the question says, you see, the left hand, not let, the F is missing over here, okay? The left half of the arch is loaded with uniformly distributed. Evaluate the reaction component, moment, radial shear and normal thrust at a section 3 meter from left hand support. So you will have to find out the moment and reaction at a distance 3 meter from left hand support. So at a section over here, which is at a distance of 3 meter from the left hand support, that means at this point D, if you take a section, you will have to find out what is the moment over here. So how do you find out moment at point D? Come, tell me, anyone? See, already we have discussed this, okay? So don't worry about this UDL point. Think about what exactly we have done for the point load problem also. So to find out moment at point D, what do you require over here? To find out moment about point D, what you will have to do? See, you know VA, you know what is the value of VA. So you can take moment of this VA about this point D, because you know the distance from here to here, because this is 3 meter. You know the load from here to here, that means out of this 6 meter load, 3 meter load is going to create moment about this D when you are going from this left hand to here. So this 3 meter, out of this 6 meters, this 3 meter load, 3 meter distance load, which is having 30 kilonewton per meter intensity, that will create moment about this D. So that is going to create moment. So you know this distance is 3 meter. Now you see there is a horizontal force acting. This is H, and you know the value of this horizontal force is 90. So whatever is shown over here, so you see this horizontal force is 90. So for this 90 horizontal force, if you want to find out moment about this point D, what do you actually require? You need to find out what is the distance from here to here. So here in case of the crown, when you have taken moment of this force H about this crown, you knew the distance from here to here. But when you are taking moment about this point D, which is at a distance 3 meter from the left hand support, you see, you don't know what is the vertical distance or in this case the lever arm of this force H, which is creating moment about D. So how do you find out the value of moment about this point D? Sorry, how do you find out the distance from here to here, or the height from the horizontal force to this point D? You see, it's very simple. The equation of the arch is given, y is equal to x minus x square by 12. So you know what is the value of x. So if you put the value of x, you are going to get the value of y. That's all. And this is your this arch is your x-axis, and this is your y-axis. So if this is your y-axis and this is your x-axis, so the equation of arch is given. So you put the value, just put the value of x, you are going to get the value of y. So if you solve this equation, so the equation is y is equal to, so very simple, you see, it is nothing but y is equal to x minus x squared by 12, right? So if you put the value of x as 3, then how much will be the value of y? That's all you will have to find out. Then you will get the distance or the height of this. You are going to get this distance. That means what I am trying to say here, see, you are going to get the distance from here to here, isn't it? So you know what is the value of x? So you know the value from here to here. What is the value distance from here to here? You know it, because this distance is nothing but your 3 meter, that is given in the question. Okay. So if that distance is 3 meter, then you see, have I written the equation correctly or wrong? So it is going to be, it's correct, so it's going to be y is equal to 3 minus 3 square, that means 9 by 12. So how much it will come? Please tell me.
2.25, sir.
2.25 meter, right? Is it correct? 2.25. 2.25, correct. 2.25 meter. So you see, you understood how to find out this distance y. So see the equation, from the equation of the arch, whatever will be given, or if it is a parabolic arch, then you will have to remember the equation as I have told you earlier. Using that equation, at a particular distance from any support, you can put the value of the x, and then you can find out easily the value of the coordinate y. Okay. Now once you have found out this value of y, then let me write it on the top, because then you can correlate the figure also. So if I want to find out the moment about d, then what will be the value of md? You see, so what will be the value of md? So value of moment md is going to be equal to, you see, this VA is going to create moment about d. So VA is going to create 45 multiplied by how much? Tell me. 45. VA value is, no, sorry, VA is not 45, right? VA is how much? VA is 135. So this, when you are taking moment about this point D, so you see your VA is going to create 135 multiplied by how much is this distance? How much is this distance from here to here? This is 3 meter, right? So you write 135 minus 3 minus, this is going to create moment. See, if this is create moment in this direction, so this portion of load will be creating moment in this direction. So you see 135 minus 3 minus how much will be this distance from here to here? This distance from here to here, you see, this is actually 3 meter. The intensity of load is 30 kilonewton per meter. So 30 into 3, this is the total load, and it will be acting at a distance 1.5 meter or 3 by 2 from this point D, because for this portion it is 30 into 3, then it will be acting at half of the distance from here. So it is going to be 3 by 2. That's all. Okay. So this is your moment due to the UDL, and the left portion is your this H. You see, this is creating moment in this direction, this is creating moment in this direction, and this H is also going to create moment in this direction, right? So whatever moment will be created by this VA is creating about this, actually you see this VA is creating on this, it is actually clockwise, this is creating anti-clockwise, and this is also going to create a anti-clockwise kind of moment, right? So if you see this is anti-clockwise, then this is going to be minus of 1, how much? Minus of 1, or what is the value of H we have calculated? H
90, sir.
90, yes. So h is going to be 90 multiplied by how much will be the distance? 2.25.
2.25.
Yes. So this will be your value of MD. Is it clear or it is not clear? So you see 135 multiplied by 3 minus 90 into 2.25 minus 30 by 3 into 3 square. It is nothing but you see 30 by 3 into, if you calculate this, it will be similar to this one, WL square by 2. It will not be 3, it is written wrong over there, okay. So it is not correct. Here it is written 30 into 3 square by 3. It will not be 3, it will be 2, okay. Is it clear? So if you do that, if you do the calculation, then you are going to get the value of MD. So what is the value of MD you are getting? Please calculate and tell me.
67.5, sir.
67.
67.5.
67.5. Everyone is getting 67.5. Has anyone calculated?
Yes, sir. 67.5.
67.5. Okay, 67.5 kilonewton meter. Okay, so you see there is some mistake over here. Okay, so this is not correct. Okay, this calculation is, they have done some wrong here, because you see 135 into 3, 135 into 3 is your moment for this vertical force, then horizontal force moment is 90 into 2.25, absolutely correct, and this UDL is going to create moment of 30 into 3 into 3 by 2, because for this distance 3 meter, half of this distance, at a half of this distance 3 by 2 it will be acting and it will be creating moment. So this is your moment MD. Is it clear? So now you should be able to calculate moment about any point in the arch, right? Everyone is clear about this, right? Now the next point is your radial shear and normal thrust. Okay, radial shear and normal thrust. So the last point we will discuss now, that is your radial shear and normal thrust, and let's see how do you know it, how do you do it. So you see radial shear and normal thrust, if you see have we done any mistake or we have done correctly? 45 130, no, absolutely correct, no problem. So you see, if you want to find out the radial shear, then how do you find out radial shear? If you remember in the previous class, or the problem where we have discussed about this point load, I have spoken about radial shear. You remember that? You remember this? You remember this diagram? We have spoken about. So this is your point load, we have said, and then this reaction, then horizontal force, and then what happens? There will be horizontal direction force and there will be vertical direction force. So there will be a force coming along the tangent of this, and there will be a force coming perpendicular to the tangent of this. Okay, so these two forces will be called as radial shear and normal thrust. Okay, so normal thrust is basically your acting normal to it, and radial shear is along the radial direction. So absolutely what you have to do, sorry, not absolutely, what you have to do to find out the radial shear and normal thrust, first you will have to calculate this value of theta. If you remember, you will have to find out this value of theta, right? So to find out the value of theta, what you require actually, you need to know what? How do you find out this value of theta? anyone tell? बोलो, कोई तो बोलो.
Sir, from RCS equation,
हाँ?
arch
बोलो.
equation, sir.
Arch equation, correct. What we will do from arch equation? How do you find out?
सर डिफरेंशिएट करेंगे सर dy by dx.
बोलो बोलो. Tell.
सर स्लोप निकालेंगे डिफरेंशिएट करेंगे.
Slope निकालेंगे. So how do I find out slope?
सर डिफरेंशिएट करेंगे dy by dx.
Correct. Differentiate करेंगे dy by dx. Absolutely. So that is what I am asking. So you see, you will have to differentiate, right? So you see, you have the equation, this one, right? You have this equation. So you have y is equal to, see, you should not forget these steps. See, the problem characteristics remain same. Only the load is getting changed. So the methodology of solving the problem will remain same. So you should not forget, it's not different. When a UDL comes on comes and acting on a arch, the radial shear and normal thrust concepts are not going to change, right? So to find out this, you will have to find out the theta. That means the tangent point, at the point where you are asked to find out the radial shear and normal thrust, at that point the tangent, how much it will be making an angle with the horizontal, you will have to find out, right? And to do that, you know the equation of the arch. So from the equation of the arch, what you should do? You should do a dy upon dx, right? And if you do a dy upon dx for that, so if you just do, see, in the previous problem also I think we have done it. So this dy dx we have done, and then at x equal to 6 find out the value of tan theta I have written, right? So exactly the same way this problem is not going to change actually, okay? So I'll just copy and paste it over here, and then I'll write it over here. So you see the equation is this one. In this case the equation is this one, x minus x square upon 12. So what will be your dy dx? So dy dx is going to be, what will be dy dx? Dy dx of x is 1, right? And what will be dy dx of x square by 12? Dy dx of x square by 12 is going to be 2x upon 12. So in this case, in the previous problem, the distance where you are asked to find out was 6 meter. In this case it is 3 meter. So you find out at x equal to 3 what is the value of dy dx, and this dy dx, so this dy dx is nothing but your tan theta, right? So dy dx is equal to tan theta. So this, once you know this value of dy dx at x equal to 3, you can find out the value of theta, okay? So once you know the value of theta, you see the radial shear and normal thrust finding is very simple. There is nothing to worry about, right? So radial shear and normal thrust finding becomes very simple. And how do you find out? You just take sin theta cos theta components of the forces. What forces? Which forces you should consider? You should consider the forces which are creating equilibrium at this point, okay? So you will have to draw a free body diagram. So please remember, whenever you will be asked to find out the normal thrust and radial shear, you first draw the free body diagram. If you do not draw the free body diagram, you will do mistake in calculating the horizontal and vertical forces at that particular point where you are asked to find out the radial shear and normal thrust. Because once you have found out the horizontal force and vertical force acting at a particular point where you are asked to find out the radial shear and normal thrust, after that, once you know the dy dx from the equation of the arch, you know that from the dy dx you know the value of theta. that means dy dx equal to tan theta. From that, you know, once you know the value of theta, you can resolve those force components very easily to find out the normal thrust and radial shear, because one is actually your resolution of these two forces along this tangential direction, and another one is vertical to this tangent. Whatever I have shown you in the previous class through this diagram, many type of examples we have considered, and what I have said, if you remember, that you do not worry about the formula for calculation of radial shear and normal thrust. Only you will have to do what? Take the direction, correct direction from the free body and resolve the forces along the tangent and normal to the tangent direction. So if you do that, your values of normal shear and radial shear and radial shear and normal thrust will be coming absolutely with proper sign. You need not to worry about it. But if you remember the formula, then you are going to get confused. So in this case, you should be very cautious about finding out the value of the vertical and horizontal forces at that particular point from the free body diagram. And you see, that is very simple. How to do it? You know the horizontal force, whatever is acting, 90. So obviously at this point, as there is no other horizontal forces acting, so in the free body diagram also sorry, what you will get? You will get another one opposite directional horizontal force as 90. So you see, if the direction of this 90 in this direction in the free body, the direction for this force will be in the opposite direction. Please remember, if from the calculation of the horizontal force this 90 was coming in the opposite direction, then this 90 would have been also going in the opposite direction, because they must balance. You will have to consider the equilibrium in the free body diagram. Now you next see for the vertical forces, how do you consider? See, 135 force is acting upward, and then you see this load is nothing but 30 kilonewton per meter, and this distance is 3 meter. So 30 into 3, 90. So 135 kilonewton force, this is the vertical reaction which is acting upward, will be getting nullified by this downward force, that is 30 multiplied by 3, 90. So 135 minus 90, that means at this point, only this 45 kilonewton force will be acting downward. Okay, so you should be very carefully doing it, because once you know these two forces, this vertical force and this horizontal force, and you know this angle, then radial shear finding and normal thrust finding is very simple. Because what you will have to do, you will have to take 90 cos theta, 45 sin theta, and then 90 sin theta, 45 cos theta, and depending on the direction of the forces, you see the direction of the resultant forces you will be computing can be very easily found out. So you need not at all bother about the formula. Only you should be bothering about drawing the correct free body diagram, from where you should be able to find out the direction of the horizontal and vertical forces, or the final resultant forces which is acting at the particular point where you are asked to find out the normal shear and radial thrust. Okay. Now the third point is which is not asked in this question, that is actually to find out the what is called the bending moment diagram. So if you remember, for finding out bending moment diagram for arch, what you actually need to do, you need to first produce the simple supported bending moment diagram. So simple supported beam, consider same span, whatever is the span of the arch, consider the same span of a beam, and which is a simple supported beam. If you remember, I have discussed it for a point load. The philosophy is not going to change, the philosophy will remain exactly same. So what you will have to do, you will have to consider a simple supported beam of length 12 meter, and you need to find out on that 12 meter simple supported beam if a 30 kilonewton per meter load of a span 6 meter acts from the left hand support, what will be the bending moment diagram. Okay. So once you find out the bending moment diagram of the simple supported beam of the length of arch, which is exactly same as the span of the, sorry, the length of the beam will be exactly equal to the span of the arch, then on top of that you just superimpose or you just subtract the bending moment diagram, whatever you will be getting because of this horizontal force H. Okay. So this horizontal force H, you see how to calculate this horizontal force H bending moment diagram. This is nothing but H multiplied by this distance, H multiplied by this distance. So at every point you see H is going to create some bending moment like this. Okay. So if you see the philosophy of calculation of bending moment, it's very clearly written in this book also. You see, this is little bit hazy. If you see in your handout, it may be little bit more clear, but it is little bit hazy. Let me explain here. So one may draw bending moment diagram by superimposing. So that is very important. So what you have to do? You need to do the superimposition. Superimposition of what? The moment diagram by the horizontal thrust. So that is what I was telling. The horizontal thrust is going to create a bending moment diagram which will be obviously taking a shape of the equation whatever you are having, because you see the horizontal force is constant, it is a constant term. What is varying? The varying part is your y. So y, as y varies, your bending moment varies. That means because of the horizontal force, you need not to bother about the shape of the bending moment diagram. Whatever will be the shape of the arch, the same shape of bending moment diagram you will be getting because of your horizontal thrust. Because you see the horizontal thrust bending moment diagram you are going to get by H, by multiplying H with that y. And what is that y? Y is nothing but the equation of the arch. So whatever is the shape of the arch, exactly on the same shape always you are going to get the bending moment diagram because of the horizontal thrust. And you need to superimpose this bending moment diagram on top of what? Over the, you see, over the simple supported beam bending moment diagram. So simple supported bending moment diagram means you will have to take the same, you will have to take the length of the simple supported beam as equal to the span of the arch, and then load that beam with whatever load the arch is being acted upon by, and then draw the bending moment diagram. On top of that, you just superimpose the bending moment diagram because of horizontal thrust, and then finally you are going to get the bending moment diagram of the arch. So you see, to find out the bending moment diagram for a 3-inched arch, it's two-step procedure. One is you need to be very clear about finding out the simple supported bending moment diagram, otherwise you will not be able to work upon it. Okay. If you do not know how to find out the simple supported bending moment diagram because of different forces acting on a beam, you will not be able to find out the bending moment diagram of arch, because bending moment diagram of arch finding out is very simple. If you can find out the bending moment diagram of a simple supported beam of same span with the same load, on top of that you just superimpose the same shape of bending moment diagram, the same shape of bending moment as the shape of the arch. And how do you get the value? You just get the value with horizontal force multiplied by that ordinate value. That's all. Okay. So I think with this, let us conclude today's class, and already it is 4 o'clock. So let me take the attendance and then we'll stop. So I hope you have understood, and if you have any doubt in the next class we can discuss. Okay. So in the next class will be on, I think, Saturday. Okay, Saturday 10:30. So Google Meet attendance collect, members 0, refresh. Meet attendance collect. Why 0 members are coming? Members. Now it will come out. Okay. Okay, attendance is taken. Okay. So thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.